Good morning, dear students.
Good morning, sir.
Uh, I welcome all of you to the class of chemistry, my dear students. Uh, we had the last class on 7th November. Today we have our class on 23rd of November. Uh, the various topics that we are going to study today, my dear students, are the general formula for the various types of hydrocarbon that we'll see. We'll also study about the homologous series. We'll study about the classification of the hydrocarbon compounds. We'll study about the functional group and the skeleton of the hydrocarbon compound. So let us start our discussion for today, my dear students, and let us discuss the various topics that we want to study today. I hope you can see your screen, my dear students. बच्चों आपको स्क्रीन दिख रही है क्या?
Yes, sir.
क्या दिख रहा है स्क्रीन
Yes,
पे?
sir.
थोड़ा पढ़ के बता सकते हैं? स्क्रीन पे क्या दिख रहा है? थोड़ा पढ़ के बता दीजिए.
General formula for
Very good. तो चलिए, it's clear now that you are able to see the screen clearly. Let's move forward and understand the various topic that we want to study today. बच्चों आपको क्या बीच में जो स्क्रीन है उसके बीच में ऐसा कुछ पोर्शन दिख रहा है जो आपको पढ़ने में दिक्कत कर रहा है? So we have the last period, my dear students, we have studied about the alkanes, alkenes and alkynes. In this period, we are going to study in detail about their general formulas. So let's have a look to the general formulas for these compounds. Let's pay attention. First, we should study about the general formula for alkenes. So for alkene, we have the general formula CnH2n. This is the general formula for the alkenes. So the general formula for alkene is CnH2n. The first member of alkene is ethene, and this ethene is the first member of alkene homologous series. Now, why the first member has got only has got two carbon? This is the question that arises in our mind. That why does this first member has got two carbon? Actually, the first member of alkane started with one carbon. When we studied about alkanes, the first member was of methane, and that methane was of one carbon. But then alkene, why do we need two carbon? So we need two carbon because alkene have carbon double bond carbon. So at least one carbon double bond carbon is needed to remain present, and as this one carbon needed to remain present, my dear students, we'll have to show, or we'll have to study that this carbon, that the first member of alkene has got two carbons. You can see that when you have two carbon, the general formula is CnH2n. You put n is equal to 2. So when you put n is equal to 2, you get C2H2 into 2. This is how it is going. Ethene becomes C2H4. So the first member of the alkene homologous series is ethene, which is having the formula C2H4. This is how, my dear students, we study the first member of the alkene homologous series. Now, when we take n is equal to 3, my dear students, for n is equal to 3, we write the word root prop. Prop is called the word root, and we write this word root prop for uh, for n is equal to 3, my dear students. When we have n is equal to 3, we generally see or we generally write the word or word root prop for n is equal to 3. So when we have alkene, we will call it propene. When n is equal to 3, the general formula is CnH2n, so it is C3H3 into 2. That gives us the C3H6. And that is why, my dear students, your propene is C3H6. This is how you can understand. Then when we take n is equal to 4, we have 4 carbon. For 4 carbon, we write the word root but, my dear students. So when we write the word root but here, we understand that we have 4 carbon, that is why the general formula CnH2n plus 2. So it is C4H2 into 4, that gives us C4H8, and that is how we can write the formula for butane. Butene is C4H8. Same way, my dear students, for pentene, we can write C5H10, that is, this 10 is nothing but 2 multiplied by 5. So, my dear students, if we write the homologous series of all the compounds which are present into the alkene homologous series, we'll come to know about them. So, let's have look to the various compounds that are present into the alkene homologous series. Uh, let's have look to them, my dear students. The general formula for alkene is CnH2n. You can see here. So the general formula is CnH2n, my dear students. Now, if you write ethene, 2 carbon C2H4, propene, 3 carbon C3H6, you just need to multiply this number with the number of carbon with 2 so that you get the number of hydrogen. Butene, that is 4 carbon C4H8, pentene, that is 5 carbon C5H10, hexene, that has 6 carbon, that is C6H12, heptene, that has 7 carbon C7H14, octene, that has 8 carbon C8H16, nonene, that has 9 carbon C9H18, and decene, that has a 10 carbon C10H20. So, my dear students, please remember that for 2 carbon we write eth, for 3 carbon we write prop, for 4 carbon we write but, for 5 carbon we write pen, for 6 carbon we write hex, for 7 carbon we write hep, for 8 carbon we write oct, for 9 carbon we write non, and for 10 carbon we write dec. Now, my dear students, let's study the next homologous series or next. So, for general formula for alkyne is CnH2n minus 2. This is the general formula for alkyne. Again, for having carbon triple bond carbon, we need at least 2 carbon, and that is why the first member of the homologous series of alkyne starts with 2 carbon. We have CnH2n minus 2, that is C2 into H, 2 into 2 minus 2, that is 4 minus 2, and finally we get C2H2. So ethyne is C2H2. Then if you look at propine, the prop represents the 3 carbon. So here we can see C3H, 3 into 2 minus 2, that is C3H6 minus 2, that is C3H4. Same way for 4 carbon, my dear students, we can write butane. So but represents the 4 carbon. So C4 into H, 4 into 2 minus 2, that is 8 minus 2, and we can write for butane C4H6. Same way, my dear students, for all the alkynes, we can write their homologous series and we can understand their homologous series. You can see that for ethyne 2 carbon C2H2, for propine 3 carbon C3H4, for butane 4 carbon C4H6, for pentane 5 carbon C5H6, for hexane 6 carbon C6H10, for heptane 7 carbon C7H10, for octane 8 carbon C8H14, for nonine 9 carbon C9H16, and for decyne 10 carbon, my dear students. For decyne we have 10 carbon C10H8. Now if you take any example of this, my dear students, suppose you take C5H8, and if you add simply CH2 to it, you simply just add CH2. So H8 plus 2 become 10, and C5 plus 1 becomes 6. So at C6H10, you can see the next member is of C6H10. So even uh, if you take C5 and H8, and you simply minus CH2, and if you have minus CH2, my dear students, in that case what happens? 8 minus 2, that is H become, sorry, H becomes 6, and C5 minus 1, that is C4. So it goes C4 H6. So when you subtract CH2 from C5H8, you get C4H6, and this is how, my dear students, that each preceding and succeeding member differs with C5H8 with CH2 or 14U mass, and this is how we understand, or this is how the requirement for homologous series is being fulfilled. Now, my dear students, we are going to study about the classification of hydrocarbon compound. This is what it is, the classification of hydrocarbon compounds. So hydrocarbon compounds, they contain, or the compound that contains only hydrogen and carbon, they are known as the hydrocarbon compounds. This hydrocarbon compound can be classified in two type of compounds. One is known as the open chain hydrocarbon, another one is known as the cyclic hydrocarbon. Now let's first look at the open chain hydrocarbon, my dear students, and we will find that open chain hydrocarbons are also known as the acyclic hydrocarbons, and these acyclic hydrocarbons are of three types: alkane, alkene, and alkyne. Alkane has got CnH2n plus 2. General formula, these are the general formula for alkane. General formula for alkene is CnH2n, and general formula for alkyne is CnH2n minus 2. So this is how we study about the open chain hydrocarbon or acyclic hydrocarbon. For all of them, we have seen their homologous series even, my dear students. We have just studied their homologous series. Now, my dear students, we are going to study about the cyclic hydrocarbon, or they are also known as the ring hydrocarbons. These ring hydrocarbons are also known as the closed chain hydrocarbons. These closed chain hydrocarbon, the examples of closed chain hydrocarbon are cyclobutane, cyclopentane, cyclohexane, and they have the general formula CnH2n. Remember that the general formula of cyclic hydrocarbon is very similar to the general formula of alkenes. So now let us study about the cyclic hydrocarbon in detail. This cyclic hydrocarbon, my dear students, this cyclic hydrocarbon, they are also known as the closed chain hydrocarbon, or they are also known as the ring hydrocarbon. So there are three names for the cyclic hydrocarbon. They can be also called closed chain hydrocarbon. They can also be called ring hydrocarbon. The general formula for this hydrocarbon, which are known as the cyclic hydrocarbon, is CnH2n. We know, my dear students, that only two carbon cannot make ring, so or cycle. So at least three carbon are needed to make a ring, and that is why the first member of this cyclic hydrocarbon, which that start with the three carbon, and the first member has got three carbon. We know that general formula is CnH2n, and that is why it is C3H2 into 3. This gives us the C3, this, my dear students, C3, this simply gives us C3H6. So when we have N is equal to 3, we get C3H6. This C3H6 is named as a cyclopropane. This prop word represents 3 carbon. In represents that there is no double bond, and cyclo represents that there is a cyclic ring present into the compound. And this is how, my dear students, we give the names to the cyclic compounds. The same way, my dear students, you can see that the cyclopropane can also be written in the form of CH2 bond CH2 bond CH2. Now, my dear students, we can look at the cyclobutane. The word but represents 4 carbon. So this cyclobutane has N is equal to 4, or C4H into 2 into 4, that is your C4H8. You can see the structure of the cyclobutane here. I have shown for you that in this cyclobutane, you have 4 carbon bonded into the ring. Each carbon has got 2 carbons, so it is nothing but your CH2 bond CH2 bond CH2 bond CH2. And this is how we understand about the cyclobutane. The another or other few examples or another members of the homologous series that we can see here. The next member is with the 5 carbon called cyclopentane. In cyclopentane, my dear students, the N is equal to 5, so it is C5H5 into 2. So it is H5 into 2, that gives us 10. So it is C5H10. The C5H10 is represented into the pentagonal structure where we have 5 carbon bonded to each other. You can see here. And each carbon has got 2 hydrogens. So it is CH2 bond CH2 bond CH2 bond CH2 bond CH2. This is what it is known as the cyclopentane. Now, my dear students, we have cyclohexane. In cyclohexane, hex represents the 6 carbon. And you can see that cyclohexane has the formula C6H, 6 into 12, that gives us C6H12. You can see a ring, my dear students, here, which is present, and this is how we understand about the cyclohexane, my dear students. This cyclohexane has a 6 CH2 group bonded with each other in the hexagonal manner. So here we have studied the homologous series of the compounds, which are known as the cyclic compound, and the various members we have seen are cyclopropane, cyclobutane, cyclopentane, and cyclohexane. In 10th standard, my dear students, we are also supposed to learn about one more cyclic compound, which is known as benzene. This benzene is a cyclic aromatic compound, and this benzene being cyclic aromatic compound, it has actually very similar structure to cyclohexene, but this cyclohexene has got 3 double bond between the carbon, and this is how we get benzene. So you can see that benzene has got 6 carbon. Each carbon is bonded to 1 hydrogen, and this is what it makes is C6H6. So the molecular formula for benzene is C6H6, and the structure of benzene is represented in this manner. Now, one more thing I would like to share with you, my dear students, here is that we can even represent benzene in some another manner. Let me explain it to you. You can see here, I have been writing something on your screen. We have seen that double bond was here. In next case, we can put the double bond here. We can even put the double bond here, and we can put the double bond here. Dhaval Pagi, please remove the line. Okay. So here you can see that each carbon can again still combine with the 1 hydrogen, but the double bond position of the double bond can be changed, and we can represent benzene with either this structure, or we can even use this structure for the representation of benzene. You just need to have the double bond that are moved either from here to here. So if you move the double bond into this position, from this you will get this structure of benzene, and this is even the correct structure of benzene, and this is even the correct structure of benzene. Please remember that benzene has the general formula C6H6, and on the base of that you can show the structures. Now, apart from the hydrogen and carbon, carbon can form compounds. Carbon can form compounds. Those have atoms like chlorine, fluorine, bromine, iodine, oxygen, nitrogen, sulfur, phosphorus, and many more. So carbon can make compounds with many other elements apart from the hydrogen. And this is how these atoms are found as a functional group into the compound of carbon. So compound of carbon, when it possesses the element other than the hydrogen and carbon, these elements which are found into the carbon compound, they are simply known as the functional group. So my dear students, today we are going to study the definition of the functional group. Please understand the definition of the functional group, because the definition of the functional group is asked into the exam quite a few times, and you need to learn it well. So please pay attention and try to understand the definition of the functional group. We can divide the definition of the functional group in four simple sentences. An atom or a group of atoms structured in unique fashion, reactive side of the compound, and responsible for all chemical properties of the compound is known as the functional group. Let me explain now. The functional group can be an atom, that is single atom, or it can be a group of atoms. Remember, the functional group can be single atom, or the functional group may be a group of atoms structured in unique fashion. Unique fashion means it has got the structure which is not same to the another structure. So all the functional group have their own structure. All the functional group have their own structure. They have their unique structure, we can say. All the functional group have their unique structure. All the functional groups have their unique structure. Please note down. And this unique structure is not similar to each other. So each unique structure of each functional group is not same with the another functional group, my dear students. Next point, my dear students, we can understand about the functional group is reactive site of the compound. Whenever any reaction takes place, the reaction takes place at the functional group, not to the another part of the organic compound, not the another part of the carbon compound. So it is called the reactive side of the compound. Whenever any chemical reaction takes place, the chemical reaction takes place only on the functional group, not to the another part which is known as the skeleton. We'll study about that. So please remember that whenever there is chemical reaction takes place, the chemical reaction takes place on the functional group which is known as the reactive side of compound. So reaction takes place on functional group only. That is why it is known as the reactive side of the compound. And then the next point is responsible for all chemical properties of the compound. So this functional group is responsible for all the chemical properties of the compound, because all the compound having same functional group will have same chemical properties. So all the compounds of having same functional group have same chemical property. We can say that functional group is responsible for all chemical properties of the given compound. So by using this four statement, my dear students, we can understand the definition of the functional group. Once again, an atom or a group of atoms structured in unique fashion, reactive side of the compound, and responsible for the chemical characteristics of the compound is known as the functional group. Now we have seen that, my dear students, that whenever we have a carbon compound, it is having another atom other than the carbon and hydrogen. These atoms are present as a functional group. So apart from the functional group, the carbon compound has another part which is also known as the skeleton. This skeletal part of the carbon compound is made up of only carbon and hydrogen. So the hydrocarbon part of the compound is known as the skeleton, or the part of the carbon compound which is made up of only carbon and hydrogen is known as the skeleton, whereas the functional group has the atom other than hydrogen and carbon. So you can see here in the functional group, we have an atom oxygen present, which is the element other than the carbon and hydrogen. So functional group contains element other than carbon and hydrogen. It can contain carbon, it can contain hydrogen, but it must have something other than carbon and hydrogen also present in it. And this is how we can identify the presence of the functional group into the carbon compound. I hope, my dear students, you understand everything. If you do not understand everything, अगर कुछ समझ में नहीं आ रहा है, प्यारे बच्चों आप मुझसे तुरंत ही पूछ सकते हैं. You can ask me at any time. बच्चों सब कुछ समझ में आ रहा है? कुछ पूछना है? Dear students, can you respond please? हेलो बच्चों, आप मुझे सुन पा रहे हो?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay, you can ask me in between. अगर मैं डिस्कशन कर रहा हूँ, कुछ समझ में नहीं आ रहा, you can ask. In standard 10, my dear students, we need to study the following functional group. We first will study the halogen as a functional group. So we can have chloro, bromo, iodo and fluoro as a functional group. We are also going to study the various other functional groups like alcohol, aldehydes, ketones, carboxylic acids and esters. So these are the various functional groups that we are going to study into the 10th standard. Now, my dear students, this functional group also have a homologous series for them, and they have a specific way to give name to their compound. Let us try to study the homologous series of the functional group, which is known as the alcohol, and let us study how we can give the names to such compounds. So please pay attention. There are homologous series made by the compounds containing functional group. This homologous series we are going to study today is the homologous series for the alcohol. So let us study the homologous series, or let us study how can we give names to the compound which are the compound called alcohols. Let's have attention to this about the nomenclature of the alcohols. Now, when we want to give names to the alcohols, my dear students, we give them the names based on the alkanes present around them. So you have, with one carbon alkane, we call it methane, which is CH4. Now in methane, one H, if it is replaced by OH, if one H is replaced by OH, my dear students, we get methanol. So here we have methanol as the first member of alcohol functional group. Now to give their names, we can easily do one thing, that while giving the name, the E from the alkane, the E which was present in the alkane or methane, this E, my dear students, it can be removed by the suffix "ol" is added. So when the methane is, this E is removed, and instead of this E, if we add "ol," we get methanol, and this is how our methanol is CH3OH. Please understand this C, this 3H, we make it CH3 and OH, and this is how the first member of the homologous series of the alkene is this methanol. So same way, my dear students, we gave name to the various other alcohol. You can see that when we CH3OH, when it is added CH2, it becomes CH3 CH2OH. So there is a difference of CH2 in between the CH3OH and CH3 CH2OH. This is how we form the homologous series. This CH3 CH2OH can also be written as C2H5OH, which is known as the ethanol. So here we have the various members of the homologous series of alkanes. We can look at them, the various members of the homologous series of the alkane. We can have just a look to them. You can see we have methanol, we have ethanol, we have propanol, we have butanol, and we have hexanol. We have studied about 6 carbon. You can see each time when you add an extra CH2, you get the next member, and that is why each preceding and succeeding member differs by CH2, and we have 1 carbon, 2 carbon, 3 carbon and 4 carbon depending upon the number of carbon. For 1 carbon we write meth, for 2 carbon eth, for 3 carbon prop, for 4 carbon but, for 5 carbon pent, and for 6 carbon we can write hex. And this is how, my dear students, we can write methanol, ethanol, propanol, butanol, pentanol and hexanol. Please remember that each members of the homologous series of the alcohol differs from its preceding and succeeding member by CH2 or 14U mass. Let's have look to the another functional group, my dear students. Let's study about the homologous series of the functional group of aldehydes. My dear students, for aldehyde we have a suffix Al. So in aldehyde we use the suffix Al. Same way we have methane. We just put the C double bond O group. So 2 hydrogen have been removed, and out of these 2 hydrogen, a double bond with oxygen is made and we get methanol. When we give name, we just remove this E and add Al here. So it becomes methanol. You can see the various aldehyde compounds. For 1 carbon it is meth, for 2 carbon it is eth, for 3 carbon it is prop, for 4 carbon it is but, for 5 carbon it is pent, and for 6 carbon it is hex. So we have methane, ethane, propane, butane, pentane and hexane. This E is removed as al. So we can have methanol, ethanol, propanol, butanol, pentanol and hexanol. When you look at the their structures or their formulas, this CH2 when it is added, at CHO when it is added, CH2 it becomes, see this H when it combines with the CH2 it becomes CH3 and CHO, so it is CH3 CHO. Then in next time you will add one more CH2 between CH3 CHO, you get propanol. You add one more CH2 between CH3 CH2 CHO, you get butanol, and same way by adding more and more amount of CH2 group, you get next members. So each member differ from preceding and succeeding member by CH2 and 14U. First member of the homologous series, my dear students, methanol here is the first member of the homologous series because carbon double bond O is possible with single carbon, and that is why the methanol is the first homologous series of the aldehyde homologous series. This methanol is also known as the formaldehyde. You need to remember this name, which is known as the common name. Methanol is also called the formaldehyde, and ethanol is also called acetaldehyde. So please learn the common name for these compounds even, my dear students. Same way, my dear students, we study the other homologous series. We will study the other homologous series into the future periods. Like we will study about the ketones homologous series. We will study about the homologous series of carboxylic acid. We may also study some of the homologous series of the esters also, my dear students. We will study about esters, and same way, my dear students, we'll study some of the type of formulas and their Lewis dot structures, so that even if you are asked into the exam, and then, my dear students, we'll study about the isomerism. In the next period, we'll study about the nomenclature of the compounds of carbon, and in the next period, we will study about the difference between the ionic and covalent compound. Now let us revise what we have studied in today's class, my dear students. In today's class, we have studied about the general formula of alkenes, that is the homologous series of alkene. The general formula is CnH2n. Then we have studied about the general formula and homologous series of alkane. Then we have studied about the classification of hydrocarbon, in which we have classified the hydrocarbon into open chain and cyclic hydrocarbon, or acyclic hydrocarbon and cyclic hydrocarbon, or open chain and ring hydrocarbon, or closed chain and open chain hydrocarbon. The open chain hydrocarbon are of three types: alkane, alkene, and alkyne, and they have general formula CnH2n plus 2. For alkene, it is CnH2n, and for alkyne, it is CnH2n minus 2. Then we studied about the cyclic hydrocarbon, or ring hydrocarbon, or chain, closed chain hydrocarbon. The examples are cyclobutane, cyclopentane, and cyclohexane, and they have general formula CnH2n. Then we have studied about the structures of cyclopropane, cyclobutane, cyclopentane, and cyclohexane. The first member of the cyclic hydrocarbon homologous series is start with the 3 carbon, because at least 3 carbons are needed for making any ring. Apart from that, we have studied about the functional group, an atom or a group of atoms structured in unique fashion, reactive side of the compound and responsible for the various chemical characteristics of the compound is known as functional group. We have seen that the carbon compound has two parts, functional group and skeleton. Skeleton is made up of carbon and hydrogen, whereas functional group contain element other than carbon and hydrogen. Then, my dear students, we have seen the various functional group that we are going to study in 10